Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome you all in PIST Virtual Learning System Session 2020. Dear students, this lecture is for grade first year, boys and girls, subject computer science, chapter number 7, database fundamental, and this is our 44th video lecture. Dear students, in previous lecture, we had started planning a database. Planning a database is a systematic approach to the development of database that moves from concept to design and development to implementation. In planning a database, we have started some stages. So there are some steps. In previous lecture, we have already discussed problem definition, and then feasibility study and requirement analysis. In this lecture, we will continue this topic by identifying entities and attributes, and then we will start data modeling. Identify entities and attribute. This is the fourth step of database designing. After requirement identification, the next step is to identify the entities and its attribute. An entity is the main data object that is of significant interest to the organization. It is usually a person, place, thing, or event to be recorded in the database. An attribute is a property that describes any entity. For example, if employee is an entity, then the employee's name, age, and address, salary, job, all are the attributes. For example, to develop college examination system, the following entities have the attributes. The attributes will be required, like in student. Student is an entity, and the attributes of the students are roll number, name, class, section, date of birth, address. Then the next entity is course. The attributes of the course is course ID, course name, description. Then we have exam result, and attributes of exam results or exams: exam ID, exam name, start date, then exam result. And in this entity, we have marks. So assigning the names to tables and columns. Entities means a place, person, thing, or event to be recorded in the database. The name of the table, in the simple words, you can say the name of the table is called entity. So student is one entity, course is one more entity, exam and exam result is entity. And we can extend these entities with the help of attributes. So basically attributes, an attribute is a property that describes an entity. It is a characteristic and a property which can extend entity. So suppose in the student entity, we have roll number, name, class, section, date of birth, address. And in course, we have course ID, course name, description. So all these are attributes. In simple words, attributes are columns and the data items in which we can save our similar type of information. So in the roll number attribute and in the roll number column, we can just save the roll number in the form of number. The name attribute is used to save and store your names, the names of the students, the same type of data. Then class, section, date of birth, and address. So all these are the examples of attributes. Once entities and attributes are identified, entities are converted to tables and attributes to columns of the tables. So dear students, here point to be remembered. So student is an entity, and in simple words, student is a table. Once entities and attributes are identified, entities are converted into tables and attributes are converted into the columns of the table. There are no standard convention for naming tables and columns, but all names should be meaningful and consistent throughout the database. So there is no common and no significant rule for naming of the column name, but we can use the similar type of the name relevant data, in which we can save the relevant type of data. Suppose in roll number, we can save the registration number and the roll number of the student. Student name represent the name of the student. Class represent the class of the student. Section represent the section of the student. So we can use the relevant type of the name and give the relevant caption to each column and attribute. For example, student for students table, in case of attribute, meaningful name should be used whenever possible. For example, the college exam system may have the table name student and the column attribute may be assigned the names roll number, name, class, section, date of birth, address. And here on your screen, you can view a table on which we have, this is basically, it is an entity, student entity. Okay, in the entity we have attribute, and attributes are columns like roll number, name, class, section, date of birth, and address. All these are attributes, and this complete information is called an entity, and in simple words, it is a table, and the columns are called attributes. So entity, it is a real world item, concept that can exist on its own. It may be an object, or it may be an object with conceptual existence, company, job, university, course. An entity type defines collection of entities that have same attributes. Entity type in a database is defined by its name and attribute. Entity instance is a single occurrence of an entity type. So entity, it is a real world item, concept that can exist on its own. It may be an object, place, or person. So entity set is a set of entities of the same type that share the same properties. Example, set of all bank customers, companies, trees, holidays. Entity type defines a set of entities that have the same attribute. Name of entity, employee, attributes, name, age, salary. Name of entity, company, name, place, like this. So entity types and entity sets. An entity type defines a collection or set of entities that have the same attributes. Each entity type is described by its name and attributes. An entity set is the collection of all entities of particularly entity type in the database at any point in time. Entity sets usually have the same name as entity type. So here you can view on your screen, suppose we have entity type car and attributes are year, model, and make. So suppose here we have an entity set Toyota Camry 2005, Toyota Yaris 2009. So these are entity set. Entity type is car, and here we have entity set, and the attributes represented by the oval shape. Always remember that you can put your entity in rectangle box and you can represent your column and your attribute in oval shape. Attribute. Attributes are the properties that describe the entities. Attributes are the properties that describe the entities. Attribute names are enclosed by ovals and connected to their entities by single line. Set of attribute values of a given attribute is the value set or domain. So here on your screen, we have one more example of the entity employee. Employee is an entity, and here you can view the attribute on your screen, which can be represented by ovals and connected with the help of single line. On your screen, SSN is one attribute, then salary is one attribute, B date, date of birth, so it is one more attribute. So here we can view the entity and attributes on your screen. So attributes, an entity is described using a set of attributes. All entity in a given entity set have the same attributes. Our choice of attributes reflect the level of detail about entities. So here on your screen, you can view the most common example. Here, the entity is student and attributes are ID, name, address, and age of the student. So you can represent your entity with the help of the rectangle box, and you can represent your attribute with the help of oval shape. And all these things are connected with the help of single line. For each attribute associated with an entity set, we must identify a domain of possible values. Like domain associated with the attribute name of persons might be the set of 20 character strings. The properties of attributes of entity set, number of attributes must be settled. Attributes type are simple. Names of the attributes are different and unique. So suppose the attribute is a characteristics of an entity are called attribute or property. An entity may have many attributes. The attributes are used to define object or entity. So one more example you can take is teacher, and teacher is an entity. Name, gender, last degree, and appointment date, pay scale, nationality, and telephone number, all these are attribute and represented by an oval shape. The name of the attribute is written inside the oval shape, and it can connect with the help of the single line. So here is a difference between the entity and attribute. An entity is an object in RDBMS that is used to model and store information. Attribute, an attribute is a characteristics to define an entity. Entity represents the main objects of the RDBMS. An attribute describes the entity. Entity, a row or a record in the table. An attribute, a column in the table. So this is a difference between the entity and the attribute. The next topic is data modeling. Data modeling is the process of designing logical structure of a database with a diagram using text and symbols to represent the way data needs to flow. This diagram is called entity relationship diagram, ERD, entity relationship diagram. Data models define how data is connected to each other and how they are processed and stored inside the system. Data models are built during the analysis and design phase of a project to ensure that the requirements for a new application are fully understood. A data model can be through of a diagram or a flow chart that illustrates the relationship between data. Well-documented conceptual, logical, and physical data models allow stakeholders to identify errors and make changes before any programming code has been written. So data model designers often use multiple models to view the same data and ensure that all processes, entities, relationship, and data flow have been identified. There are several different approaches to data modeling, and data modeling basically is a process of designing a logical structure. Logical structure, it is a diagram or a map, and it is related to the ER diagram, entity relationship diagram. Data models define how data is connected to each other with the help of entity relationship diagram, with the help of entities, attributes, and relationship. How your data can flow. You can build DFD, data flow diagrams, and you can use ERD. So basically it is a designing of logical structure of database. How your data can flow. So a data model can be through of diagram or a flow chart. It's a diagram or a flow chart. It means it can display the flow of your program, how your program will flow, and conceptually, logical, and physical data model, how it can represent your data, how it can take input from the user. So each and everything is cleared in this data modeling. So we have different types of data modeling models. Conceptual data modeling. In conceptual data modeling, identifies the highest level of relationships between different entities. So in conceptual means that in conceptual, you can represent the level how your data is conceptually interrelated with each other with different entities. The conceptual view of your data. Then we have enterprise data modeling. Similar to conceptual data modeling, but addresses the unique requirement of a specific business. It is similar to conceptual data modeling, but addresses the unique requirement of a specific business. Then we have logical data modeling. Logical data modeling, which describe the specific entities, attributes, and relationships involved in a business function, serves as the basis for the creation of the physical data model. So before going to start physical data model, we have to complete logical data modeling, which can specify the entities, attributes, and the relationship involved in the business function, serve as the basis for the creation of the physical data model. In the last, we have a physical data modeling. It represents an application and database specific implementation of a logical data model. So it represents an application and database specific implementation of logical data model, which you will develop with the help of attributes, entities, and relationships. So before start the physical data modeling, you have to create logical data modeling and physical data modeling, basically based on your logical design, your logical data modeling. So physical data modeling represents the application and database specific implementation of logical data modeling. Conceptual database design, process of constructing model of data used in enterprise independent of all physical consideration. Logical database design, process of constructing model of data used in an enterprise based on specific data model like relational, independent of particular DBMS and other physical consideration. Physical database design, process of producing description of implementation of database on a secondary storage, describe base relations, fill organizations and indexes, design used to achieve efficient access to data, and any associated integrity, constraints, and security measures. So designing methodology, structured design approach using procedures, techniques, tools, and documentation aids in conceptual database design, constructing an information model independent from all physical consideration for an enterprise, and logical database design, building an organization database based on a specific data model, and physical database design, implementing a database using specific data storage structures and access method. When a system developer designs a new database system, one crucial task is to identify and state the data needs of organization. This describes how the data elements in the systems are grouped. So the following terms are used to build a picture of the data requirement: entity, attributes, relationship, and the key. The first thing is entity. So when you are going to start a data modeling, the first term and the first thing is required and must be clear is entity. So an entity is a person, place, object, event, or concept about which the organization wishes to record the data. So entities should be things that are readily recognized by anyone working in the enterprise. So entity is a thing in the real world with an independent existence. It may be an object with physical existence like person, car, house, employee, or it may be an object with conceptual existence like company, job, university, and course. So entity, basically anything that is participating in the system is known as a data entity or object. An entity can be a person, place, thing, or event for which data is collecting and maintaining in the system. An entity is always identifiable property. So we have examples of the entities are like person, place, object. In a person, we can consider teacher, player, doctor, all these are entities. Then place, country, city, object. In object, you can consider toy, furniture. So all these are the entities, and you can represent your entities in a rectangle box. Then we have an attribute. What is an attribute? The basic unit of information about any entity. Occurrence attributes may be local to the entity, name, address, or inherited by the relationship from another entity. Eventually, those attributes which migrate into the physical design become column in the database table, and related terms are data elements, columns, as in a data flow diagram, columns of a database table, and a data items. So attribute basically is a property of an entity. Attribute is a property of entity. It's a characteristics. An attribute is a property or a characteristics of an entity. So examples of attributes associated with the customer include customer ID, surname, initial, title, address, and in student entity and attribute, the student ID, student name, class, subject, all these are the attribute of the student. And in the exam entity, we have attributes like exam ID, exam name, start date, result, like this. So what is an attribute? Like an entity, an attribute represents something of significance to the business. An attribute is a specific piece of information that helps describing an entity, quantify an entity, qualify an entity, classify an entity, specify an entity. So an attribute has a single value. Basically, attribute has a single value, and it is used to extend your entity. Attribute is used to extend your entity. It's a property or a characteristics of entity. So an attribute is a name property of a class that describes the range of values that instances of the property may hold. A class may have any number of attributes or no attributes at all. The student name, address, student ID, date of birth, all these are attributes of the student entity. Next is relationship. So a relationship is a link or association between entities. An example is the link between dentist and the patient. So in database, relationships are association between tables that are created using joint statements to retrieve data. Both tables can have only one record on each side of the relationship. Each primary key value relates to known or only one record in the related table, and we can create the relationships with the help of the keys. So in previous lectures, we have already discussed about the keys: primary key, candidate keys, composite, foreign, and secondary and super key. So we have already discussed it. Primary key is used to create the relationship between the tables. And when we can use primary key as a reference key to another table, it is called the foreign key. So keys basically are very important part of relational database model. They are used to establish and identify relationships between tables, and also to uniquely identify any record or row of data inside a table. A key can be a single attribute or a group of attributes where the combination may act as a key. And in real world application, number of tables required for storing the data is huge, and the different tables are related to each other as well. Also, tables store a lot of data in them. Tables generally extend to thousands of records stored in them, unsorted and unorganized. Now, to fetch any particular record from such data set, you will have to apply some condition. But what if there is duplicate data present, and every time you try to fetch some data by applying certain condition, you get the wrong data? How many trials before you get the right data? To avoid all these, keys are defined to easily identify any row of data in a table. So Keys are basically, it is an attribute used to identify a record in a database. Keys are used to create links between tables to avoid duplication of data in various tables. So basically the database keys are used to remove the duplication of data from database, and with the help of keys you can create a relationship. So here on your screen you can view one entity, the student. This is a student entity, and the attributes are student ID, name, class, section, date of birth, and address. And on your screen you can view a key, that is a primary key, and this primary key is can be used for the relationship. We can use this primary key as a reference key in another table as a foreign key, and we can create a relationship with the help of this primary key. So keys are the very important, and these are used to create a relationship. So relationship is a logical connection between different entity, and the relationship indicates how the entities are connected with each other. So we can we can establish the connection with the help of the keys, and we can use the primary key and the foreign key to create the relationship between these database tables. So dear students, inshallah in next lecture we will continue this chapter. Till then, Allah Hafiz.